Okay, welcome to lesson 3.3. Today we will be graphing an inequality in two variables. Our objectives are to draw boundary lines, graph inequalities in two variables, and then locate the solution area. In the past, you have graphed inequalities in one variable on a number line, but today we'll be using both x and y in order to graph an inequality on a coordinate plane. Remember that an inequality is a greater than or less than, or a greater than or equal to, or a less than or equal to. So here's a less than or equal to, a greater than or equal to, a less than, or a greater than. So remember that the line on the bottom, if there's a line on the bottom, that means or equal to. So that single line means it's or equal to. Let's go over some key questions first, some essential questions, some terms you need to know. First thing is, what is a boundary line? Because we will need to graph a boundary line in order to graph an inequality. Well, a boundary line is a line that separates the coordinate plane into two parts. So it looks very similar to the line that you would graph when you would graph a linear equation. But it's called a boundary line when we're dealing with inequalities. Second question is, what is the difference between graphing an equation and an inequality? And I would make sure that I was taking notes right now in your notebook. So if you need to pause this video and go ahead and write some of these down, because you'll need to know these for the practice that follows. So the difference between graphing an equation and an inequality, if you think about it, visually an equation has an equal sign. An inequality has a greater than or equal to, or a less than or equal to, like we talked about before, or a greater than or less than. So it's going to change how our solutions look. If we have a greater than, for example, then it could be all solutions greater than a certain point. Okay, so let's look at the definition. There is no difference except for the style of line, dashed versus solid, and the shading of our solution area. So again, we have a solution area versus a solution point. We won't just have one point, we'll have a whole area, some area that's greater than something or less than something. And then this is curious, dashed versus solid. So we'll be looking at that. When do we use a solid line for the boundary as compared to a dashed line? A solid line is used when we have the less than or equal to on the bottom here, or greater than or equal to. So again, anytime I see this line down here at the bottom, I know that I have a solid line because that means or equal. So that means the line is part of our solution. So it's or equal. Okay, a dashed line is used when the inequality sign is just a less than or a greater than. The dashed line means that the points fall on the line are not solutions. So we do not include the points that are on the line. Let's look at some examples. So here's our first example. This equation is already in y equals mx plus b form, so it's very easy to graph. Remember that this -5 is our y-intercept. Okay, and remember what we said, you graph this just like you would a regular equation, no difference except for that you have a solution area and you have a dashed or a solid line. So I'm going to plot my y-intercept down here at -5. Here's my slope. This 2/3 represents my slope, and that's no different than a regular linear equation. So from my y-intercept, I have a positive slope of 2/3. So I go up 1, 2, and I go over 1, 2, 3, making sure that I am in the positive direction, which I am. And I'll do another one, up 2/3. So the key here is determining if I draw a solid boundary line or a dashed boundary line. Well, if I look at my equation, it says less than or equal to. In that case, I know that I have a solid line because of the or equal to at the bottom. So I'm going to take and draw in a solid boundary line. Okay, normally I would be finished if I was just doing a linear equation, but we have an inequality. So the key is that I want to shade all the y's that are going to be less than or equal to my line. So would that be above or below my line? Hopefully you are thinking below, down here. Okay, because these y's down here are going to be less than my boundary line. So you would shade down here. Any point in this shaded area will be a solution in this inequality. So if I pick a point, let's go ahead and pick any point in here. Why don't we randomly pick this point right here. So this point, you go over 5 and down 4. So the coordinates of this point are 5, negative 4. If I take this point and I plug it in here, it will be a solution. Okay, so if I go ahead and plug in my y, which is negative 4, so I'm replacing y with negative 4, and that's going to be less than or equal to 2 over 3 times 5 minus 5. So what I'm looking for is to see that my left side will be less than or equal to my right side. Well, to multiply 2/3 times 5, think of 5 as 5 over 1. So 5 times 2 is 10. And 10 divided by 3, we don't know. We'll just leave it here for now, minus 5. If I go ahead and use my calculator and do 10 divided by 3, I would get 3.33333 forever. I'll just do 3.3. Negative 4 then has to be less than or equal to 3.33333 minus 5. And that would be approximately a negative 1.7. So negative 4 is in fact less than negative 1.7. Less than or equal to, I should say. Okay, so any point I pick in this yellow area should make this inequality be true. Let's go ahead and graph the second inequality here. If I look at it, it's not in y equals mx plus b form, so I can't really graph it like this. So what I want to do is I need to move the 4 to the other side, so I need to solve for y. So that means I need to divide all my terms by 4. And let's see what we get. We get y is less than negative 5/4 x plus 4. 16 divided by 4 is 4. Now I can graph this. So again, here's my y-intercept at positive 4. My slope is a negative 5 over 4. So from my y-intercept, I can go up or down 5 for my rise. So I'll go ahead and go down 1, 2, 3, 4, 5 to here. And then I need to go left or right 4 to ensure that my slope is negative. So I need to go to the right 4. 1, 2, 3, 4. That way, if I draw a line between these two dots, I will have a negative sloping line. So again, my question is that going to be a dashed line or is that going to be a solid line? Well, if I look at the inequality sign, it is just a less than. There is no equal sign. So I know that my boundary line would now have to be dashed. So any of the points that are on this line are not going to be solutions to my inequality. My final step then is I do need to shade. So I'm going to look at my purple equation down here, the one that I wrote in y equals mx plus b form, and I want to shade all the y's that are less than my line. So if I think for a moment, I'm either shading down below or up above. Well, the y's down here are going to be less than my line, so I would shade the solution area below my line. All these points are solutions to my inequalities. And I could do like I did on the top equation, and I could pick a point, plug it in, and make sure that my left side was less than my right side if I wanted to check. All right, let's do one more example, and then let's try an example in Khan so that you'll know how to do your practice. Okay, so here we have an example where once again we are going to have to put it in y equals mx plus b form. And in order to do that, I need to move the x to the other side. So I have 9 x's, so I'm going to subtract my 9 x's to the other side. What I'm left with on my left side is 3y Don't forget about my inequality sign. Now on my right side, these are not like terms. I cannot combine them, so I have to write them both. I'm going to write the negative 9x first, and then the minus 6 behind it. Finally, I have to solve for y, so I need to divide all my terms by 3 in order to solve for y. 3 divided by 3 is just 1, so I get y is greater than negative 3x minus 2. So I just divided negative 9 by 3 and negative 6 by 3. Now I can graph this. My y-intercept is down here at negative 2, and my slope is negative 3 over 1. If there's nothing below it, remember that it's 3 over 1. So I'm going to go up 1, 2, 3, and then I'm going to go to the left 1 in order for my slope to go into a negative direction. Now I just need to draw my boundary line, and my boundary line is going to be dashed because I have a greater than sign, not a greater than or equal to sign. Okay, my final step then is to shade. So looking at my orange equation, I want to shade all the y's that are greater than my line. And the y's that are greater are going to be up above here. So right up here. Okay, so some shading problems. Okay, so any point up here will be a solution to my inequality. All right, let's do our final example. In this example, we will once again have to put it in y equals mx plus b form. So in order to do that, I'm going to move the x to the other side. It's a positive x, so I'm going to do the opposite. I'm going to subtract x. And I'm left with 3y greater than or equal to, I'll go ahead and write the x term first. So I have a minus x, and then I have a positive 18 here. Okay, and then I just need to divide all terms by 3. 3 divided by 3 is just 1y, and y is going to be greater than or equal to. Now this says negative 1x over 3, so this is negative 1/3 x, same thing, plus 6. And this will be your first con practice problem that you will have. So what we have here is y is greater than or equal to negative 1/3 x plus 6. So let's go to our con account and try to graph it. Now remember that when you go to con, you will always need to log in at the top. Now on these problems, you only need to get 3 in a row. If you can't get 3 in a row, that's okay, but just make sure you've tried enough to where you feel comfortable. Go ahead and check for a hint if you need a hint, but don't just stop at 3 unless you get 3 in a row. Try some more, a little bit more than just that. Okay, so let's look back. We said that our equation was y was greater than or equal to 1/3 x plus 6. So our y-intercept is 6. Let's go ahead and plot our y-intercept. So I'm going to pick one of these points and I'm going to put it at the y-intercept. So I'll go ahead and put this orange one here. I'll drag it over to my y-intercept. Now looking back at my problem again, my slope is a negative 1/3. So what I need to do is I need to take my second point, and starting from my y-intercept, I need to go up 1 and over 1, 2, 3. And it was a negative 1/3, and my line is sloping negative. Okay, now again, double checking our equation. Our sign is a greater than or equal to. So think to yourself, should that be a solid line or a dashed line? And we know a greater than or equal to is a solid line. The final thing we need to do is figure out which side to shade. Should we shade above or should we shade below? And there's a little toggle here. As you can see when I click, it goes to the bottom or it goes to the top. So if I look at my equation, I want to shade all the y's that are greater than or equal to my line. So greater than or equal to my line. Well, right here above, they are greater than or equal to my line, so I should be fine just like this. all these points in this blue area are solutions. So I'm going to check my answer, and it says I'm correct, and now I can move on to my next problem. You'll notice the next problem is already in the y equals mx plus b form, so this will be easier to graph. You could put 1 point on 7. Notice we don't have any math related to this, we just are graphing this line. Our next point, we are going to look at our slope, which is 1 over 1, positive. So I'm going to go up 1 from our y-intercept and over 1. And then once again, I need to determine, do I need a solid line or a dashed line? Since it's less than or equal to, that's the key, or equal to, I do need a solid line. And then I just need to figure out, do I shade above or do I shade below? If I look at my inequality, it's less than or equal to, so I'm going to shade all the y's that are less than or equal to my line. So it looks like I'm in the right place. All right. That concludes our lesson on graphing inequalities. So at the end of this lesson, now you understand and can draw boundary lines. You are able to graph inequalities in 2 variables as well as shade and locate the solution area. So go ahead and try the practice on the next page.